Hi Math Tube. This is Unit 7, Lesson 4, and this is on page 175 of our workbooks, quadrilaterals and circles. And if we were in the classroom, we'd be using a compass to see if we could draw a circle that passes through all 4 of the given quadrilateral's vertices. And in A, B, and C, what we're given is a quadrilateral. Remember, a quadrilateral has 4 sides. So any of these 3 shapes that you see here all have 4 sides to them, and they're all a quadrilateral. So in the lower right area of your page, if you could sketch a circle, and then on your circle, if you could put 4 points. Your 4 points could be absolutely anywhere as long as they are on the circle. So now that you have your 4 points on the circle, I'd like you to connect them with straight lines to create a quadrilateral. So I'm going to connect my points with straight lines to create my quadrilateral. And let's name my circle so we can talk about it. So put a center on your circle and label it with a capital C. So in this picture, I could say that my quadrilateral, since my quadrilateral is inside my circle, we say that the quadrilateral is inscribed. So the quadrilateral is inscribed in circle C. So it's inscribed in circle C because it's inside my circle. And we can say that the circle is outside my quadrilateral. We can say that circle C is circumscribed about the quadrilateral. So these are 2 ways to describe my diagram. My quadrilateral is inside or inscribed in circle C, and circle C is outside or circumscribed about the quadrilateral. If this is done in a specific way, we're going to learn today that the opposite angles in the inscribed quadrilateral, and I'm going to abbreviate it QUAD, are supplementary. In other words, they're going to add to 180 degrees. So let's take a look at that. So the opposite angles in the inscribed quadrilateral are supplementary. So let's take a look at 4-2 on the next page. So let me grab my highlighter, and I want to look at this circle. We know that angle R is 105 degrees. And angle R is an inscribed angle because it's on my circle. So in this picture, I know that the arc that goes from Q through P all the way over to S, this is the arc that goes with angle R. So if angle R is the inscribed angle, then my arc would need to be twice its measure. So we've learned in previous lessons that the arc that goes from Q to S would be 210 degrees because the angle, its inscribed angle, is 105. So something else to think about, we happen to know that a circle adds up to 360 degrees. And if you carefully look at the arc from Q through R all the way around to S, so my blue arc, that would be the arc that goes with the inscribed angle P, my blue angle. So I happen to already know what the blue arc would need to be. If I took 360 minus, so 360, the entire circle, minus 210, I would get 150 degrees. I know that my blue arc is 150 degrees. Therefore, I know that angle P is the inscribed angle, I know that angle P is 75. Since angle P and angle R are inscribed angles for the entire circle, or 360 degrees, they're going to add to half that measure, or 180. This is where on the previous page, we wrote down that opposite angles in the inscribed quadrilateral add to 180 degrees. They're supplementary. So let's take a look at the other two diagrams. If this is the case, if 62 degrees is angle R, then I can calculate angle P. I know that between the two of them, and let me grab my highlighter here, I know that between these two angles, the 62 degrees is inscribed on Q all the way over to S. So this is my yellow angle that's 62 degrees. And I know that P is the inscribed angle for the arc that goes all the way from Q all around to S. So between the two of them, they make up the full 360 degrees in the circle. But remember, they're the two inscribed angles. So they're going to basically add up to half that, or 180. So let's take a look one more time at exact measures. If angle R is 62 degrees, then I know that my yellow arc is twice that, or my yellow arc is 120. Sorry, let me go get the right pen. 124 degrees, basically twice my angle R. And if the entire circle adds up to 360, then 360 minus 124 equals 236 degrees for my blue arc. So then that makes angle P half that, or 118. Well, again, 62 and 118 add up to my 180 degrees. So let's take a look at my third circle. If angle R is 130, then I automatically know what angle P is. I know that together they have to add to 180. So angle P would be 50 degrees. I could think of my 180 minus the 130 I know is my 50 degrees that I don't know. So down here at the bottom, one last time with this figure right here, it says, what is the value of alpha and beta? So this is my alpha and this is my beta. So in this picture, these two are the opposite angles. Remember, consecutive is when they're right next to each other. So if I could get a different color, C and F are considered consecutive. E and F are considered consecutive. They're right next to each other, one after the other. However, C and E are considered opposite angles. They're across from each other. So in this picture, I know that alpha plus beta, those measurements have to be 180 degrees. So then one last time, the big lesson, or the big focus of this lesson, is understanding that the opposite angles in an inscribed quadrilateral, which I'm going to abbreviate. Now this is with vertices, because now we're going to talk about this, with vertices on the circle. Are supplementary. They add to 180 degrees. So let's take a look at the next page I want to go to is page 179 of your workbook. So if you could go to page 179. On this page, this is the lesson summary. So I want to talk about one last focus. So this idea works for opposite angles or supplementary when all of my angles, all of my vertices are on the circle. So for example, in this picture right here, this diagram on the left, all of my vertices are on the circle. We call this a cyclic quadrilateral. So this one is a cyclic quadrilateral. And all of my vertices are on the circle. And we can say that my opposite angles are supplementary. I abbreviated both words there. So now let's take a look at the diagram on the right. In this diagram, F, E, and H are on the circle, but G is just a random point that is not on the circle. I don't really care if it's outside the circle or inside the circle, but the main point is that it's not on the circle. So this particular quadrilateral is not a cyclic quadrilateral, and therefore the vertices are not all on the circle. And so what we're studying today is not true for this type of quadrilateral. Then the opposite angles are not necessarily supplementary. So it's important to know which type of diagram that this works with. And so a diagram like one on the right would not be one I could use with this sort of work. So let's take a look one last time. This is the same as we just did. In this one, the idea again is that my beta plus my alpha angles would be 180 degrees, and this particular quadrilateral would be a cyclic quadrilateral because all of my vertices are on the circle. Why don't you make sure that you read through the lesson 4 summary and understand the vocabulary, and that would be the end of our lesson. Thank you.